Hi everyone, I am Dr. K. Sujatha from Physics Department, Vellala College for Women. Now we discuss about LED, that is light emitting diode. What does mean by light emitting diode is a diode that gives off either visible light or invisible infrared when forward biased. So nowadays, one of the most common ways to generate light is light emitting diode. So the first figure shows that the schematic symbol for LED, that is the arrows pointing away from the diode indicates that the light is emitted by the device when forward biased. So LED, which is having different features, that is first one is lower energy consumption and longer life, which is having more than 20 years, and third one is that fast on or switching. Then LED are not made from silicon germanium because which is having an indirect band gap semiconductor. What does mean by indirect band gap semiconductor is that is in the figure first one shows that the maximum level of valence band and minimum energy level of conduction band do not occur at the same momentum of electrons. Hence, during the recombination of electrons and holes, momentum of electrons that can be changed. So, the photons originated from these electrons will be utilized for electrons momentum. But in the case of direct band gap energy, maximum level of valence band and minimum energy level of conduction band can occur at the same momentum of electrons. Hence, recombination of electrons and holes, momentum of electrons can be changed. So, originated from photons can be originated from these electrons can not provide the momentum of electrons. So, the second figure indicate that the direct band gap, which is having the same energy gap. So, LEDs mostly made up of gallium, phosphorus and arsenic. Depending upon their quantities of applying different materials, that is gallium arsenide or gallium phosphide, they can be produce a red light or green light. So what is the theory of this light emitting diode is that when light emitting diode is forward bias, the electrons from N-type material cross the PN junction and recombine with the holes in the P-type material. So these free electrons are in the conduction band and higher energy level than the holes in the valence band. So when recombination takes place, the recombining electrons release energy in the form of heat and light. In germanium and silicon diodes, almost the entire energy is given up in the form of heat only and emitted light is insignificant. However, in materials like gallium arsenide or number of photons of light energy is insufficient to produce quite intense visible light. So this is the figure, this is the graph in between the radiator light and intensity of light. So this figure shows that the intensity of radiated light is directly proportional to the forward current of LED. So both are directly proportional. So next one is application of LEDs. LED can be used as a power indicator, that is it is used to indicate that the power is on or off. When switch S is closed, the power is applied to the load. So at the same current which should be flow through the LED, then the light should on. It indicates the power is on. So that the resistor RS in series with the LED ensures that the current rating of the LED is not exceeded. Second application is that it can be used as a 7-segment display. That is, LEDs are often grouped to form a 7-segment display. So the first figure shows that the 7-segment display, it contains 7 LEDs. That is A, B, C, D, E, F and G. So it can be shaped as a figure of 8. Each LED is called a segment. If a particular LED is forward biased, that LED or segment will light and produce a bar of light. By forward biasing various combination of 7 LEDs, it is possible to display any number from 0 to 9. For example, you have to take A, B, C, D and G. So these are light up, then the display will show the number 3. Similarly, if LEDs C, D, E, F, A and G are light up, then the display will show the number 6. To get the number 0, all segments except G are lit. So, thank you.